Hi, this is video number 2, and may I remind you that these videos are made specifically for grade 9 in Egypt. Today we are talking about uniform and non-uniform speed. Have you ever heard about these terms, uniform speed and non-uniform speed? Did you ask yourself before what is the difference between them? The word uniform means that constant, the speed is constant, the speed doesn't change. And to keep the speed constant, then the moving object must cover equal distances in equal periods of time. Take a look at this picture and you will find that I have a moving car. From 0 minute to 1 minute, between these 2 points, I have time which equals 1 minute and the car is covering 1 kilometer. From minute number 1 to minute number 2, and there is a duration here which is also 1 minute, and the car is also covering 1 kilometer. From minute number 2 till minute number 3, there is a duration which equals also 1 minute, and again the distance equals 1 kilometer. So I have here a car that covers equal distances, which is 1 kilometer in equal period or during equal periods of time, which is 1 minute. So 1 kilometer in 1 minute each time. That was the uniform speed, covering equal distances in equal periods of time. So what do we mean by the non-uniform speed? I guess it's obvious. It's quite the opposite. If the uniform speed is a constant speed, a speed that doesn't change, then in the case of the non-uniform speed, the speed keeps changing. So I have a definition here that's mentioned in your book that the object is covering different distances in equal periods of time, or I can say that the object is covering non-equal distances in equal periods of time. Now you can look at these two different pictures. Each one is representing a type of speed. The lower one is representing the uniform speed, and the upper one is representing the non-uniform speed. In the lower one, as we agreed, I have equal distances in equal periods of time. But take a look at the one that represents the non-uniform speed. I have a car that's covering equal distances in different periods of time. Of course, as we said, I can have a car that covers different distances in equal periods of time. In the previous video, we learned how to calculate speed. We were talking specifically about uniform speed. It's distance over time. But now we need to learn how to calculate the non-uniform speed. We will take examples of mathematical problems. If we want to learn how to calculate the non-uniform speed, we need to learn about a new term, which is called the average speed. What is the average speed? To understand the average speed, we need to imagine a car that is moving in the city. In the city, we find the traffic, the traffic jam. So in each part of this movement of the car, we will find that the speedometer is recording a different speed for each distance or for each part of this journey. So in this case, we cannot calculate speed by using the distance over time, but we need to calculate it by using something else, which is the average speed. The average speed equals total distance that's covered by the object in motion divided by the total time. Okay, now we will see some of the simple examples of how to calculate average speed. And we have one of these examples in front of us. So we have a driver who is moving from city A to city B. And the trip is being divided into 3 segments. So the driver covered 30 kilometers in 1 hour. Then in the second segment, the driver covered 30 kilometers in half an hour, and in the third and last segment, the driver covered 30 kilometers in 0.25 hours. As we agreed, when we are trying to solve mathematical problems, we need to follow certain steps. So the first step here, if I'm asking you to calculate the average speed, then the average speed rule is average speed equals total distance over total time. Step number 2, we need to collect the data or information that is given to us in the mathematical problem. And we agreed that we have 4 segments. Each segment is covering 30 kilometers, so we have 30 kilometers and 30 kilometers and 30 kilometers. These are the distances given to us in the mathematical problem. The first 30 kilometers was covered in 1.5 hours. The second 30 kilometers was covered in 0.5 hours, and the last 30 kilometers was covered in 0.25 hours. Now we need to see how do we apply this rule, the average speed rule. The average speed equals total distance over total time. Total distance 30 plus 30 plus 30, the 3 segments, divided by the total time, 1.5 hour for the first 30 plus 0.5 hour for the second 30 kilometers, and finally 0.25 hours for the third or the last 30 kilometers. This means total distance is 90 kilometers and the total time is 2.25 hours, so it's 36 kilometers per hour. Let's make a quick revision of if I ask you in this problem to calculate the average speed in kilometer per hour, as we did, and also in meter per second. Remember, to calculate the average speed with meter per second, all we have to do is take the numerical value, which is measured by kilometer per hour, and divided by 3.6, which equals 10 meter per second. This was the first example. Let's see another one. This is another one. I have a car that travels 3 hours. It travels 30 kilometers in the first hour, 45 kilometers in the second hour, and 75 kilometers in the third hour. Okay. The same steps. Step number 1, I'm asking you to calculate the average speed, and this is the rule for the average speed, equals total distance over total time. Now I need to write all the data given to me in the mathematical problem, so I don't lose any of the points. I have 3 segments, 30 kilometers in the first hour, 45 kilometers in the second hour, and 75 kilometers in the third hour. So the periods of time here are equal to each other, 1 hour, 1 hour, and 1 hour. Now we apply total distance, 30 plus 45 plus 75, over total time. I have 1 plus 1 plus 1, this is 3 hours. So 150 divided by 3, so the average speed here equals 50 kilometers per hour. Our last example here is that I have again an object that's covering a certain trip via 4 segments. So I have this table and I'm asked to calculate the average speed. Same steps. Step 1, average speed, total distance over total time. Speed 2, I need to write the data. So all the distances given to me, 30 kilometers, 45 kilometers, 50, and 65. And the first segment, which is the first 30 kilometers, was covered in 1 hour. The 45 kilometers was covered in 2 hours. The 50 kilometers was covered as a distance in 1 hour. And the 65 kilometers, this distance was covered in 2 hours. And again, the rule for the average speed, total distance over total time, all the distances mentioned in the mathematical problem, 30 plus 45 plus 50 plus 65, divided by all the times that were given to us, 1 plus 2 plus 1 plus 2, this means 190 divided by 6, so the average speed here equals 31.66 kilometers. Now, can you think of examples of objects that move with uniform speed and examples of other objects that move with non-uniform speed? This is a very good example of objects that move with non-uniform speed, of course. because even people walking on foot, they cannot keep a uniform speed or a constant speed. They are moving fast or slow according to the conditions around them, according to people who are riding bicycles, according to people who are riding motorcycles, or even people who are riding or moving with cars that can appear suddenly in front of them. Trains are considered a very good example of object that can move with a uniform speed as long as there are no turns or curves, or there are no animals or people that will appear suddenly in front of the train. Well, that would be all for this video. I hope you like it. See you soon.